Hi folks, this is Nat, and this is going to be your video lesson on adding and subtracting with mixed numbers. We talked earlier in the year about fractions and how to add and subtract with fractions. We're going to discover that a lot of the rules that go along with that are the same for mixed numbers. And we're going to apply some of the mixed number concepts to the geometry that we've been doing recently. Let's start off with just some simple arithmetic, adding mixed numbers. And here we've got a problem, 2.5 plus 4 1/3. The first thing that we need to be aware of, just like adding regular fractions, we need to have a common denominator. We can't add halves to thirds, they're not alike. And I can pretty much ignore the whole numbers here at this point. I don't have to worry about this 2 or this 4. I'm primarily just thinking about this 2 in the denominator and this 3 in the denominator. And a common denominator for halves and thirds is going to be sixths. And if we recall, I'm going to need to multiply each fraction by the same thing on both the top and the bottom. So to make a 2 into a 6, I need to multiply it by 3. To make a 1 into a equivalent fraction, I have to multiply by the same 3. So 1 times 3 is 3. 1/2 becomes 3/6. Over here in 4 1/3, I have to multiply the 3 by a 2, and so I'll multiply the 1 by a 2 as well. So 1/3 becomes 2/6. Now I have a common denominator. And I'm ready to just slap those numbers right back on. 2 and 4, and we add. Nice thing here is there's not a whole lot to this. We just add whole numbers to whole numbers and numerators to numerators. Denominators, if you remember, in fraction addition stay the same. So the 6 will be the same. So 2 plus 4 makes 6. 3/6 plus 2/6 makes 5/6. And I'm done. And for a lot of mixed number addition problems, that's really all there is to it. I just need a common denominator, and I add the different pieces together. There is one situation where it gets a little bit, where you add a step. Let's look at that. Let's say I'm adding 4 5/8 plus 4 5/6. Again, very first step anytime I have to add or subtract anything with a fraction, mixed number or otherwise, is that I need a common denominator. So I'm looking here at the 8 and the 6. I can see that an 8 is made up of a 2 and a 4, a 2 times a 4, and a 6 is made up of a 2 times a 3, so they both have that 2. So the things I'm going to be multiplying are 4 and 3. So 6 times 4, 8 times 3, and if I did it to the bottom, I have to do it to the top. I need my equivalent fractions. So multiply the 8 times 3, now I'll multiply the 5 times 3 as well. Multiply the 6 times 4, I'll multiply the 5 times 4 as well. And that gets me my common denominator, which in this case is going to be 24. So let's rewrite this problem. 4 5/8 will be 4 and 15 24ths. And I'm going to be adding that to 4 and 5/6 becomes 20 24ths. Same deal as before. I'm just going to add whole numbers to whole numbers, fractions to fractions. So 4 plus 4 is 8, and 15 24ths plus 20 24ths is going to be 35 24ths. Now here's where there's one extra step that I have to deal with. If you didn't notice, I have a mixture here between a mixed number and an improper fraction. I've got the whole value, but I've also got this improper fraction where the numerator is bigger than the denominator. This is really not an okay way to write an answer. So what I need to do is convert that to a proper mixed number. And the way that I do that is break these things apart and think about how many wholes can I get out of 35 24ths. So 35 24ths is made up of one whole, 24 24ths, plus an extra 11 24ths. So I can get one whole out of it, here it is, and have 11 24ths left over. What I'm going to do is just add that whole to my other whole values. So 8 plus another whole is going to be 9. And then the 11/24 that's left over just gets tacked on at the end. So when we end up in a situation where there's a mixed number with an improper fraction attached to it, all we do is take however many wholes we can out of the fraction, add those to the mixed number, or to the whole number, and that's it. Now we're going to look at subtracting mixed numbers, which is very much the same. Here we have 3 5/8 minus 2 1/4. Again, the most important thing is that idea of a common denominator. We can't do anything until our denominators are the same. No adding, no subtracting. So in this case, I see that an 8, which is 2 times 4, is made up of a 4. So I don't have to change the 8 at all. I'm just going to multiply my 4 times a 2. And I'll do that to the top and bottom. Hopefully we're getting the sense of this. And so I'm going to have 3 5/8 completely unchanged minus 2 2/8. And from here on out, it's exactly like it was with adding. I'm not going to worry about the things separately. I'm just going to subtract whole number from whole number, fraction from fraction. So 3 minus 2 is 1, and 5/8 minus 2/8 is 3/8. And I'm done. So again, a lot of the time this will be all there is to it, and that's a pretty good situation to be in. There are, however, situations, about half the time, where we're going to have to follow an extra step. And let's look at one of those. So here we've got a situation where I've got 6 4/9 minus 5/6. If it makes it easier for you to think about it this way, 5/6 could be a mixed number. It just has 0 wholes. So we could rewrite this whole thing if we wanted to as 6 4/9 minus 0 wholes and 5/6. It's not a big deal. But either way, we're still going to have to find that same common denominator that we talked about before. So I see my 9, which is a 3 times a 3, and my 6, which is a 3 times a 2, and they both have a 3. I'm going to be multiplying my 9 by 2 and my 6 by 3, which will give me a common denominator this time of 18. And I do the same thing to the top that I did to the bottom. So it's going to be 6 8/18 minus 0 if you want, and 15/18. And here we get to the difference, which is that I cannot take 15/18 from 8/18. Again, if we notice, 15/18, which I'm trying to subtract, is bigger than 8/18. So I can't actually do that. The solution here is to borrow, just like you would any other time you can't subtract. So when I look at this whole, 6, it's got a lot of 18ths in it. I need to borrow some 18ths so that I can make 8/18 bigger. And when we borrow with fractions, we always borrow a whole value, which is just the same thing in the numerator and denominator. So I could borrow a lot of different things. I could borrow 5/5, that would be a whole. I could borrow 6/6, that would be a whole. 7/7 would be a whole. So a lot of choices, and I always base my decision off of the denominator of the fraction. I see that I've got 18 in the denominator, so what I'll end up borrowing is none of these here, but 18/18. That's a whole that I can easily add to the 8/18 that I already have. So I'm going to take one whole away from my 6, and it will become a 5. And I'm going to take that 8/18 and I'm going to add it to the 18/18 that I borrowed, which is going to give me a grand total of 5 26/18. Now, if you're thinking about it, you're going to notice that this is the exact opposite of what happened at the end of an adding problem where I ended up with an improper mixed number. But when I'm borrowing, this is actually the goal. I want to have an improper mixed number so that I'll have enough to subtract. So I'm going to take that 5 26/18, and now I can subtract my 15/18. Something to be aware of, we're never going to change the number we're subtracting. We'll never ever borrow the number we're trying to take away. But now I'm good to go. So again, whole number minus whole number, fraction minus fraction. 26/18 minus 15/18 is going to be 11/18. And 5 minus, remember, 0 wholes is just going to be 5 wholes. So my answer is going to be 5 and 11/18. And I'll show you one more time that we end up with kind of some similar stuff happening. Here I have the problem 8 minus 3 and 1/9. So I've got a whole number and I'm taking away a mixed number. This is another borrowing situation, and here's why. When I look at that 8, it's like having 8 and 0/9. I've got no ninths. So when I go to take away 1/9, I can't do that yet. So same idea as before, I have to borrow. So what I'll do is I will take one whole away from the 8, it's going to become a 7. And I have to think, what am I going to borrow? Well, my denominator here is in ninths, so it makes sense to borrow ninths. I'll borrow, in this case, 9/9. And when I add those to the 0/9 I had, it's just 9/9. So 8 wholes is the same as 7 and 9/9, 7 and 1 whole. And that makes it really easy then to go ahead and do my subtraction. 9/9 minus 1/9 is going to be 8/9. And 7 minus 3 is going to be 4, and I'm finished. So this ends up actually being a lot easier because there's no common denominator I have to think about, because when I borrow, I get to borrow anything I want. If this side had been in eighths, I would have borrowed 8/8. If it had been 55ths, I would have borrowed 55 55ths. So that ends up working actually pretty well. And just in case you are needing a couple more examples, we're going to do 2 more maybe. If you're feeling good, you can just skip to the end and do the practice problems, but for anybody who kind of wants a couple more, here we go. So 2 3/5 plus 8 3/4, the very first thing I'm thinking is a common denominator. 5 and 4 don't have anything in common, so I actually just have to multiply them by each other. So I'll be multiplying my 3/5 by 4s and my 3/4 by 5s. And that, if I rewrite it, is going to be 2 and 12/20 plus 8 and 15/20. Put that together. 2 plus 8 is 10. And 12/20 plus 15/20 is 27/20. Now, if we're paying attention, we're going to notice that improper mixed number, which we don't like. So I see that I can get 20/20 out of 27/20. So I'm going to change this. I'm going to think of it as 20/20 and 7/20 separately, because I want to take that whole and add it to my 10, which is going to make it 11, and then 7/20 left over, and I'm done. So when we finish our addition, we always stop to think, is it a regular mixed number, or is it an improper fraction or improper mixed number that I need to fix? Here's another subtraction problem. Again, common denominator is always my first thing before I make any other moves. So these are nothing alike, so I just multiply them by each other. 5 times 3, 3 times 5. Change the top accordingly, and I end up with 3 and 5/15 minus 1 and 9/15. Now here's the point in subtraction of mixed numbers where I have to decide, do I need to borrow? I see that 9/15 is bigger than 5/15, so yes, I have to borrow. I'm going to have to take that 3, borrow a whole from it. It's going to become a 2, and I'm going to add 15/15 onto the 5/15 that I already had. That's going to be 2 and 20/15. So I've ended up with that same idea of that improper mixed number, but that's okay because I'm going to use it to subtract 9/15. 20/15 minus 9/15 is going to be 11/15, and 2 minus 1 is going to be 1, and I'm finished. And here are your practice problems for the lesson.